Okay, we are going to look at reciprocals today. So a reciprocal is something you've been using for a long time in math. You probably just didn't even realize it. I know you've heard the word before though. So a reciprocal is when you take something and you flip it upside down. So remember in middle school and / high school when we taught you how to divide fractions and we taught you the old flip and switch rule. Well, what you were doing here was multiplying by the reciprocal. Okay, so you've actually been using reciprocals your whole life. All a reciprocal means is that you take something and you flip it upside down. So the numerator becomes the denominator becomes the numerator. It's literally all it means. So, for example, if I have 2 and I want to know its reciprocal, it's half. And if I have 4/3 and I want to know its reciprocal, it's 3/4. Therefore, if I have x and I want to know its reciprocal, it's 1/x. And then, if we keep going with that line of thinking, if I have x plus 5, its reciprocal is 1/x plus 5. And if I have x squared, its reciprocal is 1/x squared. All you're doing is taking whatever you've got and flipping it, which quite often means putting it under 1. Remember, all of this stuff can be written as fractions if we need it to. So to find its reciprocal, you're just putting it under 1. Now, that's lovely. However, as soon as we start putting x's in here, it's going to create some problems when we look at it as a function and start graphing. So, like if I have a function f of x, and that function is x, and if I take the reciprocal, that means 1/f of x is 1/x. Now, you can substitute in just about anything for x and it'll work, right? So, but what happens if we substitute in a 0? What if we have 1/0? Will it work if x is 0? Can you graph this function? And the answer is no. We cannot have a 0 in a denominator because it's undefined, right? It's no dice, no bueno, can't do it. We cannot have a 0. So this reciprocal function, 1/x, is all good as long as x does not equal 0. And that's because it creates an undefined value in the denominator. So you cannot have that. It's not graphable, it doesn't exist, it's not something we can have. So let's take that a step further. What if your original function is x plus 5? So your reciprocal function, therefore, is 1/x plus 5. Now, what number in this denominator will create 1/0? What number can x not be? Well, if I come over here, if I need to figure out what will give me 0, then I'm just going to kind of solve. So that's going to say x. If x is -5, then I will get 0, which is undefined. Therefore, x cannot be -5. Okay, so this is a non-permissible value because it leads to an undefined. So therefore, we're always going to have to identify in these problems what our non-permissible value is. And sometimes there's 2 non-permissible values. It's whatever number creates a 0. And you just have to find it. And all you do is you take the denominator and you set it equal to 0 and solve. And that will tell you. Let's look at that just for like one more second. what if we have like 1 over, what if our reciprocal function is like 1 over 2x plus 3? So if I need to know what my non-permissible value is, I'm going to take my 2x plus 3, set it equal to 0 and solve. So now I know that if x is negative 3 halves, then it will create an undefined function. Therefore, my non-permissible value says that x cannot be negative 3 halves. Make sense? Okay, now there's something else that occurs from this place. So I'm hoping that you've already graphed 1 over x. But if not, let's review this process. So if our original function is f of x equals x, then our reciprocal function is 1 over x. Now, if we take a table of values, and we've got our x, and now, of course, this is going to be like our reciprocal function. So let's say we say like -3, -2, -1, and then I'm going to kind of go even further here and go -half, 0, half, 1, 2, 3. If I do that, then I'm going to say 1 over -3, which is what? -1/3. And 1 over -2 is -1/2. And 1 over -1 is -1. And 1 over -1/2, what is 1 over -1/2? 1 divided by -1/2 is the same as 1 times -2, right? So -2. And then 1 over 0, of course, is undefined. So I can't even find that. It doesn't exist. I can't graph it. It's not a number. It's undefined. And now I've got 1 over half again, which is 2, and 1 over 1, which is 1, and 1 over 2, which is half, and 1 over 3, which is 1/3. So if I come graph this thing, what's going to happen? We need to look really carefully at this. Let me find my graph. Hold on. Hello, Mr. Graph. Okay, here's my graph. So I'm going to graph this. So I'm going to go over to -3 and down to 1, 2, 3, and down 1/3. Then I'm going to go over 2 and down 1/2. And I'm going to go over 1 and down 1. Then I'm going to go over 1/2 and down 2. Okay, 0 is undefined. So just for now, I am going to highlight that place in red. Okay? It's undefined. It is a wall. It cannot be crossed. It doesn't exist. It's ungraphable. Okay, so I'm going to keep going. I'm going to go over 1/2 and up 2, over 1/2 and up 2, and then I'm going to go over 1, up 1, and then I'm going to go over 2, up 1/2, and I'm going to go over 3, up 1/3. Do you see how these are making this like curve? And this is making this curve? Well, what's happening here is if I go in and if I add, what if I add another one? What if I add -1/4? What would that be? What's 1 over -1/4? It's 4, -4, right? So if I went to 1/4, I'd be going 1, 2, 3, 4. I'd be going all the way down here. And the same thing would happen if I added a +1/4. I would get 4, right? I would go even higher. I'd go up here. What these are doing is they are creating a graph that looks like this. They are slowly approaching certain numbers. This graph is slowly approaching the undefined value of 0. See how these are they're like vines that have run into a wall and they just start growing up the wall. they're growing up this undefined value of 0. And this is doing the same thing, except it's going down. It's just going to keep following this wall, and it's going to get closer and closer and closer and closer, but it's never going to quite touch it because it can't. So this red line that we've just created is called a vertical, because it goes up and down, a vertical asymptote. Here's how you spell it. A vertical asymptote, which obviously we're going to call the VA because that is far too much to write. So as you get closer, and you can imagine, like we just went from 1 to half to a quarter. If we went to a fifth, if we went to an eighth, a tenth, or a 100th, we would be getting that much closer and that much further up and down the y-axis, right? So these are called the vertical asymptote. And if you'll notice, the vertical asymptote occurs wherever you have an undefined value. All right, so let's go review what that means up here. Let's go back to where we were. In these, remember these guys? So the same thing would happen in this. We had 1 over x plus 5. So our value, our non-permissible value that gives us an undefined value is now going to be our vertical asymptote. And that's because it created an undefined region. Okay, so that the non-permissible value that you found in your denominator is creating a vertical asymptote that the graph cannot graph. So that means if I was going to graph this particular graph, over here at -5, I would have that red line, and nothing would be able to cross it. So my graph would look like this. My graph would do this. It would follow it all the way up, and it would go like this. It would follow it all the way down. My graph cannot cross this asymptote. Now I'm drawing this red asymptote in here because it like to help you visualize it, but it's not really there. That's why I'm drawing it in this highlighter. Okay, let's go to one final piece of this. So here we are. We have these functions. So let's say we have 1, or y equals x plus 2, and then our what's it called? A reciprocal function of that would be 1 over x plus 2. So now we know that in this function, we can look at this pretty quick and see that our vertical asymptote is going to be at -2. So -2 is off limits, and it's vertical, which means that's on the x-axis, right? So if we graph this, let me pull up my graph again. So if we graph both of these functions in the same place, which is quite often what we do, we're going to graph both functions on the same graph. So if I go graph x plus 2, I've got a y-intercept at 2, a slope of 1, and it's just going to kind of cruise along like this, and life is grand, and there we go. If I make a table of values and I graph this reciprocal function, I already know that my what's that thing called? Vertical asymptote is over here at -2. So I'm going to kind of fill this in because I know I can't cross that. And if I go and graph my reciprocal function, you are going to find that it does this. Okay, it creates these two areas. It's got two branches of the graph that do this, and they don't quite touch that vertical asymptote. Now, here's what we want to look at now. These graphs are going to cross, if I was a better grapher, these graphs are going to cross somewhere. There's going to be 2 points where they intersect, and those places are called invariant points. So the invariant points are where they intersect, okay? And we want to know where those invariant points are. So here's the beauty of this. They are always, for right now, always at 1 and -1. See that? Where y is 1 and y is -1. And they equal each other at those places, right? Which is pretty cool. So to find my invariant points, all I'm going to do is I'm going to take either of these functions, whichever one looks easier, which for the record is x plus 2. I'm going to take my x plus 2 and I'm going to make it equal to 1, and I'm going to make it equal to -1, because it's going to be 1 and -1 where they cross. So then I'm just going to solve, and I'm going to be like, okay, x equals -1 and x equals -3. So the coordinates of where these happen, remember, we made your y 1 and y -1. So therefore the coordinates of the invariant points are -1, 1, and -3, -1. And don't forget, this 1 and this -1 are kind of given to you. Like, we're solving for those. We know that that's where the y's happen. We just have to figure out what x goes with that. And then sure enough, if you come back over here and look at the green dots that we found, those green points, that is definitely -1, 1, and this is definitely -3, -1. That's going to work all the time. Now, if you have a quadratic, you need to follow the same steps. Don't let a quadratic get you. If you've got 1 over x squared, okay, this is not a huge deal. All you're going to do is set that equal to 1 and -1 again. If you've got a quadratic of any sort, you're just going to set it equal to 1 and -1. You're going to have to take square roots. You're going to have to do positive and negatives, because remember, the square root of 4 can be 2 or -2, right? So apply all of the same stuff to the quadratics. Okay, let me do one quick example. So let's say we had x squared minus 16 as our f of x. So our reciprocal function is 1 over f of x. So 1 over x squared minus 16. When you go to find your non-permissible values, you need to factor this. So you need to say x plus 4 times x minus 4, right, equals 0. So therefore we know that x is 4 and -4. So that means we have 2 vertical asymptotes, right? And also 2 non-permissible values. So there's your vertical asymptotes. As far as finding the invariant points, you have to do this for your invariant points. You have to set x squared minus 16 equal to 1 and to -1, just like we did before. But this time, you're going to end up with multiple answers. You're going to end up with x squared equals 17. Well, take the square root, and you get x equals the square root of 17, which is going to be like, I don't know, 4.1. But it's going to be 4.1 and -4.1. So therefore, you still just used 1 as your y value. So the coordinate is 4.11 and -4.11. And then same deal over here. Do that again. Move your 16 over, and now you have x squared equals 15, square root. So x equals, I don't know, we're going to say 3.9 and -3.9, because when you take the square root, and then your y value on that's -1, right? So here we go. So you actually end up with 4 invariant points when you have a quadratic and you have 2 vertical asymptotes, right? But the process doesn't change. You're still setting it equal to 1 and -1. It's just the algebra that changes. Don't let that get you. Okay, I hope this made sense. Good luck.